back to our channel. In today's video, we are going to talk about gas laws. So, gases are defined as a state of matter which consists of thousands of particles that have indefinite shape, size, and volume, and follows the structure and dimensions of their containers. Unlike other states of matter such as solids and liquids, gases have lower density and has more space, allowing particles to move very fast and collide into one another, causing them to diffuse or spread out until they are evenly distributed throughout the volume of the container. So Charles' law is a gas law proposed by Jack Charles from the 1780s that described how gases tend to expand when heated. It shows the temperature-volume relationship. The volume of a fixed amount of gas at constant pressure is directly proportional to its absolute temperature. Going into detail, this equation shows that as absolute temperature increases, the volume of the gas also increases in proportion.
For this experiment, you would need a balloon and an Erlenmeyer flask containing 10 ml of water. Now gently cover the opening with the balloon, making sure that no air could go in or go out. Now bring out the alcohol lamp, as well as your tripod, with the wire gauze. Now with the use of your thongs, gently transfer the flask on top of the tripod. While waiting, you may bring out a 500 ml beaker and fill it with ice or ice-cold water. Notice that as the water heats and rises in temperature, the volume of the balloon would also increase as well. That is because the molecules inside the balloon are all excited and moving at a great amount of speed. Because of the temperature, thus they consume more space in order for them to move freely. Now how about at cold temperatures? With your thongs, tightly transfer the flask onto the beaker and slowly submerge it little by little. Now observe what happens to the balloon as this takes place. What happens? Opposite to inflating, you could see the balloon losing its shape. That is because the molecules inside are much more slower than before and do not require that much space to occupy it.
For a more detailed and valued experiment, let us say that a nitrogen gas, which weighs 0.6 liters, would be heated from 300.15 Kelvin to 350.15 Kelvin. With constant pressure, let us now find the final volume. So using this formula of Charles' law, we would now derive the first volume, which is 0.6 liters, to be multiplied with the second temperature, 350.15 Kelvin. Deriving the formula, we would now divide it to the first temperature, which is 300.15 Kelvin. We would now arrive with an answer of 0.7 liters, which would then prove Charles' law having constant pressure and a direct relationship between the volume and the temperature. To see Charles' law in action, try to step out into a chilly place with a helium balloon in your hand. Notice that that balloon tends to crumble, but when you go into a warm place, the balloon takes back to its original shape. This proves Charles' law since the helium takes up so much space in warm temperatures.
Boyle's law is an experimental gas law that describes the pressure-volume relationship published by Robert Boyle in 1662. It states that the volume of a fixed quantity of gas at constant temperature is inversely proportional to pressure. Going into detail, this equation shows that as volume increases, the pressure of the gas decreases in proportion. Similarly, as volume decreases, the pressure of the gas increases.
For this experiment, you would need a bottle, scissors, a pair of balloons, as well as your pins. The first thing to do is to grab your bottle and poke a hole with your pin at the bottom. The next step, take one of the balloons and cut them in half, taking the bigger portion and placing it at the bottom of the bottle and closing even the pin inside. Now take the other balloon and place it at the opening of the bottle, but enclosing with the lid and through the outer portion, like this. The end result would look like this one, enclosing both the top and the bottom portion of the bottle. Now observe as you pull down the balloon at the bottom of the bottle and see what happens to the balloon inside of it. Notice that as you pull, the balloon inside the bottle would tend to deflate. Why is that? Because as you pull the balloon below, this causes the air molecules inside to have a high amount of pressure. And because of Boyle's law, high amount of pressure would cause a decrease in the volume of the balloon. So as you can see, the balloon would then deflate and would lose its form. The air molecules inside that bounce off the walls also occupy the space given by the volume inside.
For another example of Boyle's law, what final pressure would be needed to compress a 196.0 liters of air with 1 atmospheric pressure into a cylinder of 26 liters? So, deriving the formula that we have here, the first volume, 196.0 liters, would be multiplied with the first pressure, which is 1.08 atmospheric pressure. Deriving the formula that we have here above would be divided with the second volume, 26 liters. And we would now arrive with a pressure of 7.54. Thus, 7.54 atmospheric pressure would be the required pressure to compress the 196 liters of air into the 26 liters of cylinder, thus proving Boyle's law of having constant temperature and an indirect relationship of volume and the pressure. To see an example of Boyle's law, try taking a flight inside an airplane. As you go into a higher altitude, notice that your ears would start to throb. That is because the pressure inside and outside of your ear chambers are very different, and that is why your ears tend to pop. This is why passengers are given foods or little things to eat, because as they swallow, the air would expand in through their throat and outside.
Now, the Gay-Lussac's law was proposed by Joseph Louis Gay-Lussac between 1800 and 1802. It discovered the relationship between the pressure and temperature of a fixed mass of gas kept at a constant volume.
For this experiment, you would need hard-boiled egg, a glass bottle, and matches along with some papers. Light the match and notice that as it burns, immediately place it inside the bottle and place the hard-boiled egg on top of the opening. Make sure that at the end part of the bottle would stay hot so you could see and observe what would happen to the egg. This experiment would prove Gay-Lussac's law that with a high amount of temperature, thus inside the bottle, would then also result to a high amount of pressure, which would then result to the egg being inside the bottle. At constant volume, you would notice how the egg slowly or immediately slides off inside the bottle.
With an example of Gay-Lussac's law, what pressure would be required at a constant volume of gas of 1 atmospheric pressure with a temperature of 293.15 is heated up to 461.15 Kelvin. So using this formula that we have here, the pressure 1.0 atmospheric pressure, would be multiplied with the second temperature, which would be 461.15 Kelvin, divided by deriving this formula that we have with the first temperature, which would be 293.15. We would now arrive to a value of 1.57 atmospheric pressure. This would then prove Gay-Lussac's law with constant volume and a direct relationship between pressure and temperature. You may ask, how is this related to real life? So when you heat an aerosol can, tendencies are that that can would go to explode. That is because the heated pressure inside raised into a temperature that was so high, thus proving Gay-Lussac's law.